Hey everybody, welcome back to the Hilltop Aarow project. Steve Basic from the Build Show. And today we're going to talk about something that's a little true to my heart, right? I have a beautiful house behind me. You know, you've seen a bunch of my videos already. You're going to see a whole bunch more about this house, the Hilltop Aarow project. It's on a set of concrete piers. You can see here we have partial basement. We have a beautiful cantilever deck. But the thing that I really wanted to talk to you about that, again, is true to my heart is, you know, I'm a licensed architect, but I came up through the building science world, which is very rare for an architect. A lot of architects, you work for architecture firms and you learn about designing great buildings and you go on to design beautiful looking buildings. But the problem with that is a lot of those beautiful looking buildings lack building science. And then you go into the building science world, and there's a lot of buildings out there that are designed and built zero energy houses, but then they lack the aesthetics. And so you're really torn between these two worlds. And when I went out on my own, one of the things that I told myself is that I have to spend my career taking sound aesthetics and architecture and sound building science and knitting them together to create that really good product that not only looks good, but performs just as good as it looks, right? And I think this Hilltop Aarow project, you know, I love all the projects that I do, but this one here is really, to me, the heightened success of where sound building science was integrated into sound aesthetics to make both of them work very well, right? We have a house that 60% of the house sits on brick piers, but we don't have the penalty of the energy losses through that floor system because there isn't a basement under it. We have a cantilever deck that isn't attached to the building, it's attached to the concrete piers below so that we don't get that thermal conductivity through the house by just running a series of beams out through that house. So it's a really good example of that knitting together and that what I would call integration rather than application. A lot of houses that I see get designed very well, and then the architect along with the homeowner just says, okay, well, how can we apply some green building methods? This one here, it's all knitted. It's the root solution to this house is both embedded in aesthetics and in performance. Let's go back to the studio. I'll break out some drawings of this and we'll talk a little bit more about this pet peeve of mine. All right, everybody. So hopefully you enjoyed that little stint out on the job site there. I was out at the Hilltop Aarow project here a few days ago, back home at the studio, broke out the building section and talk a little bit further about the choices we make, how we innovate, how we deliver projects, and what should we be thinking about. And I'm not saying what should we be thinking about for today or tomorrow, but what should we be thinking about next week or a year from now or 10 years from now. So break out that drawing. I'm going to give you some of my personal thoughts today. So stay tuned. Of course, Big Red is going to join in because he's going to highlight some areas and we're going to talk about things. So let's have at it. All right. So I broke out the building section. I thought that was the most relevant document here in the construction documents for us to talk about. And of course, my good friend Big Red joining us here. We got quite a bit to talk about today. You know, we talked about the sound integration of building science and aesthetics and architecture. You know, for years and years, I think the profession of architecture has relied on, you know, business as usual and designing buildings and then merely applying building science to it in the end and trying to figure out a way of how do I make this a greener building or a more sustainable building or whatever term you want to throw out there. But the reality is that we have the knowledge and there's really no excuse for us not to be designing buildings that are not only beautiful buildings, but integrate sound building science procedures and details into making that beautiful building not only look good, but perform better than it looks. So, here's that building section. I just wanted to run through kind of a bunch of the things that run through my head when I look at a building section like this, or I'm putting together a building like this, because, we started out with an idea. And remember, that idea was, this building that was very solid. And then as it went on, it kind of diminished into the air and gently touched the ground, right? That was, some architects, I was taught that was the partie, right? Partie is basically the general idea of the building. And so you have that idea, but we have to make that idea a reality. We have to put it together, and we have to make sense of it. And we need to make sense of the ability to properly sequence the building in construction, but we need to make sure that it performs good. So as I look at the building section, and some people say, oh, there's a basement, and, there's some piers, and there's a floor frame. Let me explain to you what I see. So I see the basement here, basement wall and footings, but I also see a water management challenge here and potentially here that we have to deal with. I see a thermal challenge here, as the air in the conditioned basement is going to be warmer than the ground, so the house is going to continuously trying to heat the ground. We have hydrostatic pressure that comes up from the slab that we need to worry about to make sure that we don't get water in our basement. We have, again, that foundation wall that we talked about here. Well, the same losses that we have there, there's the losses on this wall look probably something like that, right? So you have that. And the reason for the angle is that, the lower we get in the ground, the closer the temperature gets to the inside temperature. So if this is, say, 70 degrees, well, this is 55 down there. There's only a 15-degree delta. But as I get up here, this could potentially be 30 degrees. Well, across here, now that's a 40-degree delta, right? It's almost 3 times what it is down here. So we have to deal with that. And then we have that, that above grade portion, which is the worst case. We have the floor frame that comes in there, and we have to insulate that. We have to deal with the structure, right? The building can't come crashing down, so we have to make sure that certainly those details apply. But then we have our wall frame. Our wall frame is very similar to the basement wall frame in that we have to keep water out. We have to keep the energy that we provide inside the building as conditioned space from either being lost out in the winter or gaining that heat in the summertime when it might be 100 out here and we're trying to be 70 in here. Well, that 30-degree delta is always trying to balance, right? Temperature or heat flow is always from high to low, and moisture is always from high to low. Across this wall, we have what my good friend Peter Yost would call a vapor profile. Moisture is going to migrate across that wall. We have to worry about it because the last thing we want is that moisture to hit a surface and condense and become water. And then that really becomes a number one problem or a water management problem. Right? You have to deal with that. Well, once we solve it for the walls, that's all good and well, but we punch holes in our walls. And those holes are windows, right? And doors, but in this case here in the section, we have windows. So now we have to deal with that. We have to deal with that window. And not only do we have to deal with the selection of the window, the color, and the aesthetics of that window, but we need to deal with the performance characteristics of the window, the U value, the visual transmittance, the solar heat gain coefficient, all of these things. And then once we pick the window shows up on the job site, but then we got to provide details of how this window gets installed. And again, how all of those details battle our 4 control layers, right? Water management, air tightness, the vapor profile, and of course the thermal efficiency of the structure. As we move up the wall, we eventually come to the roof. Well, in this case here, this was a 1 in 12 roof. You can see very low slope, which means, you know, for every 12 inches I go horizontally, I drop 1. And notice that it is a vented roof. So we're taking air in here and it's coming out here. And when it comes out, it takes any of the moisture that migrates up there with it. But we also have to insulate it. You know, so we're up here, we insulate it, we provide that proper venting, and we need to whisk that away. And given that it's a 1 in 12, this really took some special detailing in order to create an adequate ventilation system to really bleed the air out of that attic system. And all of this stuff here, this is all pretty standard stuff in that, you know, a lot of the houses we built here in New England, they have basements, wall systems, windows, and roofs. In this case, a shed roof. You know, here we have that long vented 1 in 12 roof again. Well, this one has the vent here. So we had special detailing there. It takes in air down at the soffit and vents. Like its predecessor up high there, it also has a series of insulation. It has to deal with that vapor profile of moisture migrating through that system. So we have to put in the right materials to do the job there. Is it a question of where we want to slow down that vapor migration across here? Because we can put in materials here that do that. Or do we want it to flow nice and easy, straight and quick? These are all questions as the building professional that we need to ask. And again, we need to make sure that, you know, there's that 1 in 12 roof that not only does it perform good, but it looks good. Remember, buildings that look good, people take care of. Buildings that people take care of last a very long time. So it's all part of the system. You know, in this particular building, you know the deal. If you haven't seen some of those previous videos, go back, check them out. But I talk about a lot of these details in detail. But 70% of this house is open air underneath the floor system. It's a suspended floor system. It's on these board-formed concrete piers that hold the building up, which posed a few building challenges. It looks pretty cool. You stand on the side of the building and you get to look through these areas, and the building kind of hovers over the ground, and you say, hey, that's a really cool looking building. But just because it's a really cool looking building doesn't mean that it shouldn't perform exceptionally well, right? All rules apply, aesthetics and building science. We have to make sure that this floor assembly, like our roof assembly, does a bunch of things, right? We need to make sure that it's managing water. We need to make sure that this floor assembly, that no air moves through it, that it is an airtight assembly. We need to make sure that is vapor moving through? Do we care? If not, how do we set up the vapor profile? And a lot of these questions, understand that there is no right or wrong answer. There is only the intent that we set out to do. So if you say, I don't want this assembly, I'm just going to allow this assembly to dry to the inside, then that's a decision that you've made by putting something impermeable along the bottom here. So it slows it down, just like putting in some type of vapor retarder to slow that migration of moisture into the vented attic for whatever reason. All of these things, these decisions, like anything, they have consequences, but they have initial intents on how we make that happen. Notice from a structural perspective, this truss is not one big roof, right? I broke it with the truss manufacturer. Now, we could have broken it in a lot of places, but we didn't. We specifically broke it at this location here. The reason for that is we have this cantilever of X, and this is 2X, right? So it's at least 2/3 or 60% of that, and that allowed us to be able to engineer that 10-foot overhang on the roof truss, which adds to the aesthetics, but there's a performance criteria that not only does it look good, but it has to perform good. We don't want this roof sagging in 5 years. Clients wouldn't be very happy if they showed up and this thing started turning to a banana, right? We want to make sure it stands up. The same with the concrete piers, right? We work with a structural engineer, and we have the required structural analysis there and the attachment here, and we have that suspended floor. But not only do we have the structural criteria of the materials, but we need to make it look good, right? How far do these piers go up? There were a bunch of decisions that were in the design process that allowed us to arrive at a very specific intent and then push that through. One of the last things, this house has a beautiful cantilever deck, right? And that kind of finishes off with that kind of, deterioration of the solidity of the building as it migrates down the hill, that you have this nice basement 2-story structure that's very solid, and then you have this structure that's sitting on piers, so we're starting to see a little bit of air, and then it finishes basically with this cantilever deck that has all air underneath it, and that it's a little 8-inch piece on the truss and 4-inch piece on the edge of the deck that are the last things to touch the air. So we have met our architectural aesthetic criteria, but then we have to transform that information into buildable building science criteria, right? And in this case, it would have been very easy to just say, just like the roof truss, to come in here and say, you know what, why don't we just come back to this pier with a large LVL and we'll just bump that out. And we'll have that go out, and it'll be this big, 14-inch square block under the deck. We'll detail it so it's, looks nice. But no, we wanted that to go out to that little 4-inch piece. We wanted that taper, right? We wanted to get it to the point where we were barely a piece of the building as the last piece to touch the air. And we didn't want, from a thermal perspective, we didn't want what's happening out here to migrate inside. We wanted it thermally broken. So we basically built the house, and then we built the deck and attached it on the outside so that they don't connect. And there is no connection, as that deck could have potentially just migrated in. It would be very easy to do that. It would obviously, work structurally, and a lot of people would just consider that the standard of that's how you do the deck. But again, as building professionals, we need to strive for what is the right answer for our intent and what are we trying to do. And in this case here, my answer was a thermally broken deck that sits out at the edge of the building. So with that, that's today's video. I could go on and probably talk about this for hours, but I think you guys get the point that there's a big difference in my world between the words application and the word integration. right? Integration's where it's at, not application. We're not here to put makeup on a building. We're here to do sound building science decisions and take those decisions and wrap them around a beautiful, aesthetic, appropriate building and make them work. And use building science in our favor and use the idea of thermally uncoupling that deck as an aesthetic solution to why the building will look good. So, anyways, that's it for Big Red. He worked hard tonight. Big Red worked almost a little overtime tonight. But as we sign off here on this video and we go out tomorrow morning, wake up and get after it, let's remember, it's not always just about the science, and it's not always just about the aesthetics. We're design and building professionals. It's our job to mix the two and come up with the proper matrix to deliver a successful project to our clients. That's our job. There's a lot of choices to be made out there. There's a lot of bad choices and a lot of good choices. Hopefully, we're making good choices. And remember, good buildings, beautiful buildings, people love. Buildings people love are buildings people take care of. Buildings that people take care of are buildings that last a very long time. Remember, long live our buildings. Anyways, if you're looking for more from me, find me on Instagram, Steve Basic Architect, putting up tons of information all the time. We're having discussions online where we're pondering a lot of these questions and thinking about a lot of this stuff. So my daughter Alexandra works with me, and she's on Instagram also at Alexandra Basic. She's always posting good stuff, and she writes for Green Building Advisor. And if you're looking for even more, you can find me on the Unbuild It podcast. I team up with my good friends Jake Brutman and Peter Yost, and we have at it. We break down some pretty complex building science concepts, and we break them down into hopefully simplified concepts that are a little more easily understood, and we have a lot of fun doing it. So those guys like to try and bully me and pick on me, but I fight right back. So, and then lastly, remember the science of video watching. Again, I'm only perpetuating what I'm told here. If you need to watch these videos 6-7 times to really grasp all the content in them. So get out there, check out those videos. I have over a year's worth now backlogged in there. So go check them out. When you're done with mine, you got Matt, Jake, Wade, Brent, everybody doing great stuff. People always, I get at least 2 emails or texts a day. Where can I find out some good information? What should I be doing? How can I better myself? Where can I find out more information? You get the whole Build Show network here. We're doing webinars. We're doing our videos. Tons of information. Matt puts out a ton of great information on his YouTube channel. Go check it all out. It's all free. You get to watch it and learn from it. So a lot of great guys doing great stuff. It's all current stuff. So go and enjoy. And remember, long live our buildings.